Okay, ds dt, which is another way of saying s prime. So this is the same, this is another way of saying the same thing. So this is like saying s prime of t. There it is. So ds dt, this is like s prime of t. Okay, that's just another way of saying it. So what we have here is a rewrite. So this is going to be 6/5 t squared plus 2 t to the negative 2/3 power. Okay, and we've done these a lot, right? Or not a lot, but
a fair
recently.
amount.
Yeah, recently. And so now we want to find ds dt equals s prime. So we have 2 times 6/5 t, because that goes there. Then we have plus, we have negative 2/3 times 2 times t to the negative 2/3 minus 1.
Oh, negative 2/3 minus 1 would be negative 5/3?
Negative 5/3. Let's take that, because if we have negative 2/3 minus 3/3, that's going to be negative 5/3, right?
Yes.
So negative 5/3. And then if we put this back in like situation, we got 12 divided by 5, is that right? 12/5 t, and then we're going to have minus, well that's going to be, is that going to be 4? 4 over 3.
Yeah.
And then we're going to have that's going to be their third root there, right? And t to the 5th. Now, is there anything that looks like a product rule or quotient rule in here? A note card 11 or 12? There isn't, right?
No.
So this is one that the author of the curriculum just threw this back, kind of spiraled back. And you could have used a quotient rule for this, but what happens is it makes more work, because you'll find that this will be squared. You can still do the low d high minus high d low over low squared. You can still do that, but it's really not helpful. But this thing should be a if I didn't make any mistakes. I don't know, did I?
I don't think so.
Probably not. Got all these eyeballs checking it out. 10 eyeballs. Focused. Are you focused, Hannah? Yes, 10 eyeballs. That's fine, because I have.
You can be more.
Oh, even more. Well, yeah. Except the video that I sent out last night from this class, I saw that it had precisely 0 views. Okay.
I work every single night.
Well, you were here, okay. You were here, Hannah. So that was not for you.
There's only one person that's supposed to watch it.
No, 2 people. Maddie and Kylie.
Miami. Oh, camera's on. How you doing, guys?
I got you. I'll watch it.
Get those views.
No, you don't need to watch it unless you
If you're
need
watching
to
this
repeat
video
it.
right now, I need you to go back and watch every single video so you know exactly what's going on.
Yeah, that's for Maddie. Okay, yeah.
What?
On YouTube.
No, that's true, because that could be very helpful, and really Gavin makes a good point. Gavin makes a good point, because say you're like, because a couple of you said you were tired coming in today. Is that understandable? Yeah, perfectly understandable. But if you're not focused right now, you could focus later, and maybe you'll be able turn it up to 1.25 speed or turn it down, whatever, or pause and rewind. Yeah, that's the way you do it. All right, Gavin, thank you for your contribution. Okay,
Attaboy.
so now we have number 4. So go take a look at number 4.
Yes.
And this is also remember that table I said that was kind of a scavenger hunt yesterday? This is kind of a scavenger hunt too, if you look at it. For this, I'd recommend doing what did I show you yesterday as far as organizing? What did I show you?
Square.
Okay, this is, yeah, I did that yesterday. Okay, so Gavin mentions the square, I mean the rectangle, which is good. I'm glad you mentioned it, Gavin, but is this the proper use of that? What is this thing here? What is this thing here? This thing right here, what is this?
That's the,
What does that mean right there?
that tells you it's G divided by F.
G divided by F, okay?
So F is the low.
Right, yeah. So F is the low, G is the high. But Gavin, that was a good contribution, Gavin.
I got an answer. I don't know if it's right, but I got something.
You got something? Okay.
You're right.
Did-
Always have a good contribution.
No, he does, Gavin does.
I thought it was a great contribution, Gene.
It was an awesome contribution. It was, because what it is that what I want you to do is mentally search for things that apply. And Gavin's thinking, okay, well, we did that box thing yesterday, so does that work here? We look at it more closely, no, it doesn't work. Oh, this is quotient rule. So we put low, D low, high, D high, and then assemble everything. So I'm just explaining out loud what I want your thought process to be kind of like. Does that sound right? Yeah, that sounds really good. So we're talking about like signs of intelligent life percolating in the classroom. Carson, do you feel like signs of intelligent life are percolating in the classroom, Carson?
Exudes intelligent life.
Carson's not on camera, but he's sort of making a little gentle chuckle, sort of a
Oh,
nod.
he's chuckling on it. Big chuckles. Dude, that's a dope nickname. Big chuckles. Big
Okay.
chucks. Big chucks.
Okay, so we have I'm going to put low, D low, high, D high. So low is, yeah, F is the low, right? So F, so what is low going to be?
1.
Low is going to be 1, because that's F of 5. Really good. Okay, what's D low?
6.
6.
Negative 3.
High is going to be negative 3. And D high is 2. So now we can assemble everything together. Let's see. G, I'll call it GF. prime of 5 is equal to low d high. And what is d high? 2 minus high d low all over low squared. So that's going to be 2 plus 18, is that 20? Is that plus 18? That's 20, isn't it? Is that what you got? Okay, good. Is that what you got too, Aaron?
C.
C, okay. See, we're doing cross curriculum today. Spanish is also part of what's going on here. 20,
What does that mean?
I don't know.
Spanish, 20, 20.
Oh, I thought you said Bente. I was like, oh.
20. Well, what in Spanish it's kind of ambiguous between B and V, sort of. Haven't you noticed that in Spanish?
Yeah, Spanish is fun.
Is and different locales have different pronunciations too, of course.
Like jalapeno.
Yeah.
Favorite TV
Who wants to get him $2?
that show that movie?
I haven't.
Okay. What I want you to do is see this next exercise set here. It says classwork, analytical practice with product of quotient rules, classwork. What I want you to do is go over these problems in classwork. Do the first, let's say the first 2 of these, 1 and 2. Can you do those?
I can try.
That's right. That's what we want. We want that.
High. And D high. So you don't have to factor out the low squared, right?
Probably, usually not.
Okay.
Yeah, usually not, because you're usually just going to see that bottom thing squared. Okay, what this looks like to me is -5 over, is that what you got for that? Does that look right? Low D high. So the product of this and this minus product of that and that. Does that look right?
Yeah.
Do you
No.
have to leave it in parentheses?
You mean down here? Yeah, I just want you to leave it in parentheses, because there's nothing to be gained unless you could factor something out. But most of the time you work out these types of problems, you're just gonna have your low in parentheses squared, okay? So that'd probably be your best way to do it. Now it so happens when you have these types of expressions, just to look for patterns, usually you're not going to have a variable in the numerator. Usually it's just going to be plus or minus a constant in the numerator, because these things are the x's are going to cancel out with the, so when you see this type of rational function, this is just pattern recognition. Just look for a correct answer. Okay, and next, we have this one here. And so for this one, I would go like this. Graphically organizing. And so I put 3x plus 5, 3, and 1 minus 4x, negative 4. And then y prime is going to be that. 3 times 1 minus 4x plus, it's going to be plus, well that's going to be negative 4 times 3x plus 5. And then other than this, you can just simplify and combine like terms if there are any. So you get 3 minus 12x. And then here, everything's going to be negative with this negative 4, right? So I'm going to get minus another 12x, and then minus 20. Does that look right?
That's what I got.
So I'm going to get we're going to get negative 24x minus 17. Does that look right? Y prime. So that's what it looks like. And one thing you could do with this is, could you actually do this one without the product rule?
Maybe.
Well, you absolutely could, because what you could do is you could go ahead and multiply these together.
And then use the
So we'd have like negative 12x squared, yes, thank you. And then we'd have
3x.
Yeah, plus 3x
And then minus 20x.
minus 20x
Plus 5.
plus 5. And if we take the derivative of this, you see we'd
That's
have,
what I did.
oh, you did it that way?
Yeah,
You did it this way
I did.
instead of this way?
Yep, and then I erased it all and did it that way.
All right, yeah, you got the same thing either way.
He's a
Yeah.
genius.
No, but see, that's actually good. Yeah, no, but see, that's the way to do it, because what is you have is rattling around in your brain, you have certain things that you can do that you're ready to do, right? And so you just say, oh, let me do this, and then you end up doing what makes sense to you. To me, it's sort of a close call which way is more efficient doing it. Probably my way of doing it would be like Gavin did, just try to, because I could quickly expand that and work it out. Of course, this is where we're going into product rule. Well, if the product rule for a problem like this is not necessary, why are we even doing product rule?
For when it is necessary.
For when it is necessary, that's right. Because sometimes, right, good job, Aaron. Because sometimes if we had let's say we had a function like this, we had y equals 3x plus 5 times sine x. Now we haven't done trigonometric derivatives yet, but this is one where I guess you could still distribute and do it that way too. But there are times that the product rule is going to be really, really helpful to us. But it's just part of the set of tools available to us. That's really what it is. Okay, let's see. Do these.
You want to do number 3?
Yeah, do number 3.
Ugh.
3, 4. It's kind of a mix. 5. So kind of, yeah, you should be able to get through these.
So we're doing 3?
3, do 3 and 4.
Okay.
3 and 4. 3 y 4.
Ah, si senor.
A long time ago, I had a summer off for college where I didn't have a job, and I thought for a time I thought about going down to Mexico, and they had a program where I lived in the San Jose area. San Jose State had a program where you could actually go and live with a family in Mexico, and so you'd learn Spanish living with the family, and then you take Spanish courses during the day, so you were in an immersion type of situation. And I am telling you that was a missed opportunity, because had I really learned Spanish well back then instead of superficially like I know now, that would have opened up some opportunities for me. Yeah, Spanish, if you have an opportunity to do likewise, consider it. I gave Maddie a t-shirt last night. She seemed happy to get it.
How'd you do that?
She was over here taking the test at the testing center.
And so for number 4, we used the product rule. That looks like a lot. A trinomial.
For number 4, yeah, yeah, use the product rule. And I think what is the theme of the exercise? It says, yeah, use either the product rule or the quotient rule. So that's the direction. So So 40. Now, is this what you got for 3?
Yes.
Something like that. And another thing you see is sometimes you can see in the numerator some opportunities for factoring. We could factor out like, I don't know, 4x squared, right? So if we factored out 4x squared, we would have like 10x minus 3 or something like that. Does that look right? So we could do that, but most of the time, it's okay even without doing that, all right? And then here, why am I making myself a long box?
Next one.
Because this is room, but I need to have room for all of this writing, don't I? And then we have 6x squared minus 5, then 7x minus 1, 7. And so h prime of x is equal to 7 times all this minus these things multiplied together, or plus, excuse me, I said minus, it's going to be plus. You know something, guys? I'm just going to say that's good enough. I know we could expand and simplify and all
Why
that
were you
stuff.
kidding me?
Did you simplify everything?
Yeah, I simplified it.
You did? But
What'd you get?
did you get this far though?
Mm-hmm.
Did you get,
Aaron, tell me what you got so I can see if I was right.
I got 56x cubed.
Yeah, that's what I got.
all right,
Minus
guys.
x minus 6x squared minus 70x plus 12.
Okay, good.
We're the coolest Mr. D.
Very good, yes. You are, yeah.
Yeah, definitely your favorite class.
Yeah. I'll tell you one thing I did today during a test in Algebra 2 Honors today, second period, I was working on calculus up here. And after turning in the test, people are looking at it, I said, oh, you guys, go ahead and do 5 and 6, 2, 5 and 6. I told them that in 2 years, a lot of you might be doing this in this class. I did number 5 pretty fast, but this is what I got for it.
That's what I got.
That's what you got too? Yeah. And again, I told you the pattern, right? That you're gonna have, if you have this looking thing, type of rational function, you're usually just gonna have a number on top divided by the denominator squared. And the weird thing about this is you could actually work this out using the product rule too, in a way. But
Why is it plus 3x?
plus 3x, let's talk about that. Okay, minus minus. You got that?
The old double negative.
Old double negative.
Old tricky.
That's it. Old tricky double negative. Yep.
True.
No, that was good question though, Hannah. Good question. This one here, you could distribute here and do that, but
Oh, that also went this way.
But if you do it like this, you'll have square root of x, and here you'll have 1 over 2 square root of x. Did you get that?
Yeah.
Then you have x plus 5 and 1. This derivative here, you're going to get, this is a very common thing to take the derivative of a square root. So you'll, I hope, learn how to just make that a pretty automatic thing. And so a prime of t is equal to square root of x times 1 plus this times this, so that's going to be x plus 5 over 2 square root of x. So that should be that one worked out. Okay? I want to point ahead. I want you to work on another assignment tonight. We're going to do this one tomorrow. But I want you to do these ones. You see where it says product of quotient rule worksheet? Differentiate. There are more problems than 1 through 4, but I want you to do these 4 for the beginning tomorrow. So that'll be like a homework assignment, and we're just going to show that up tomorrow first thing, okay? It's the frequency of repetition on this that's going to help us. And so this one here should be a 10-minute assignment probably to do this, right? Because this is, you see, that's what we've been doing right along, isn't it?